Have you ever noticed the glowing, colorful signs lighting up a city at night? They paint the streets with vibrant reds, blues and greens, transforming ordinary buildings into dazzling works of art. These glowing lights seem almost magical, as if the city itself is alive and breathing with color. But behind this magic is a fascinating world of science, where invisible forces and clever inventions come together to create these stunning effects. What looks like pure enchantment is actually the result of careful experimentation and discovery. All around us, invisible gases float in the air, silent and unseen. Yet, when these gases are energized, they reveal a hidden superpower. They glow in brilliant, unique colors, each one different from the next. It's as if each gas has its own secret personality, waiting to be discovered. Picture a sealed glass tube that appears completely empty. It looks like nothing is inside, just a simple, clear tube. But when a special device is used, suddenly, the tube erupts in a burst of vibrant light, as if by magic. This is the moment when science and wonder collide. Each type of gas produces its own signature color. Neon glows, a fiery orange-red. Argon shines blue, and helium gives off a soft pink. These glowing colors are like fingerprints, revealing the unique identity of each element and showing us the hidden personalities of the building blocks of matter. This glowing phenomenon isn't just for city lights or eye-catching signs. It's a window into the very building blocks of the universe. By studying these glowing gases, scientists can learn about the elements that make up stars, planets, and even our own bodies. The secret behind this glow is a remarkable invention, a device that creates invisible energy fields, powerful enough to make gases light up without any wires touching them. This invisible energy dances through the air, exciting the atoms inside the tube and causing them to shine. Watching a gas tube light up is like witnessing a hidden world come to life. It's a stunning demonstration of how invisible forces, like electricity and energy, can create visible, colorful effects that captivate our imagination. In this chapter, we'll explore the science behind these glowing gases, tracing the story from a genius inventor who first harnessed this effect, to the incredible discoveries that followed. We'll journey all the way to the heart of the atom, uncovering how energy and matter interact to create the colors we see. Along the way, we'll meet the noble gases: helium, neon, argon, krypton, and xenon, and see how each one brings its own special glow to the world. We'll also discover the rule that connects energy and color, learning how the amount of energy an atom absorbs determines the color of light it gives off. By understanding why these gases glow, we unlock secrets about the nature of light, energy, and the universe itself. It's a journey that reveals how even the most ordinary things can be filled with wonder. So, get ready. We're about to light up the world of science and see the universe in a whole new way. The device that makes gases glow, invented by Nikola Tesla, a visionary who dreamed of wireless energy. Tesla's most spectacular invention, the Tesla coil, transforms ordinary electricity into high-voltage, high-frequency energy. When powered on, it creates crackling bolts of electricity, miniature lightning, and a powerful electromagnetic field. The coil works by resonance, building up energy to astonishing voltages. Tesla believed these coils could transmit power wirelessly across the globe. While his grandest dreams didn't come true, the Tesla coil remains a powerful tool for science demonstrations. It lets us light up sealed tubes of gas from a distance. No wires needed. Bring a glass tube filled with invisible gas close to a Tesla coil, and you're about to witness a spectacular science show. The moment the tube enters the coil's field, something magical happens right before your eyes. There are no wires connecting the tube to the coil. Just the invisible power of the coil's electromagnetic field, which energizes the gas inside the tube from a distance. The Tesla coil broadcasts energy through the air, much like a radio station sends out music. The gas inside the tube acts as a receiver, picking up this energy and responding in a dramatic way. The energy easily passes through the glass, reaching the gas atoms inside. These atoms absorb the energy, and their electrons jump to higher energy levels, becoming excited. This process is called electromagnetic induction. It's the same principle that powers wireless charging for your phone, but here, it's on full display, far more dramatic and visible. Inside the tube, Noble gases, like neon, argon, or krypton, absorb the energy and become excited. When these excited atoms return to their normal state, they release energy as visible light. The result? The tube glows in a vivid color, unique to the type of gas inside. Neon shines red-orange, argon glows blue, and krypton emits a pale lavender. Move the tube closer to the Tesla coil, and the glow becomes brighter and more intense. Pull it farther away, and the light dims, or even disappears, showing how the strength of the field changes with distance. This hands-on experiment is a powerful way to make invisible energy fields and the excitement of atoms visible to everyone in the room. It's a direct, visual lesson in how energy can move without wires, sparking curiosity and wonder about the hidden forces all around us. The coil is on, the gas glows. Simple, stunning science that brings abstract concepts to life in a flash of color. That's the magic of invisible forces at work, turning the unseen into something you can see, right before your eyes. What's happening inside those glowing tubes? Let's zoom in on a single atom. Atoms have electrons orbiting a nucleus, living in different energy levels. Normally, electrons stay in the lowest energy state, the ground state. The Tesla coil's energy boosts an electron to a higher, unstable level, an excited state. The electron quickly falls back to its ground state, releasing the extra energy as a photon, a tiny particle of light. Millions of atoms do this at once, creating the steady glow we see. The energy released determines the color. Bigger jumps mean higher energy, bluer, light. Smaller jumps mean lower energy, redder, light. Each atom's unique structure means unique color, jumps. That's why different gases glow in different colors. The glow is the atom's way of showing off its energy transitions, its atomic excitement, made visible. The stars of our light show are the noble gases, each with a signature color. Helium glows soft pink peach, discovered on the sun before Earth. Neon shines with a fiery red-orange, the classic neon sign color. Argon, common in our air, glows bluish-purple. Krypton emits a smoky white or blue-green light. Xenon glows bright blue to lavender, rare and mysterious. Radon is radioactive and unsafe for light displays. Oganesson, a synthetic element, exists only for moments in labs. Its glow is still a mystery. Each noble gas reveals its atomic identity through color. Their glowing spectrum is a rainbow written by the elements themselves. These gases light up more than signs. They light up our understanding of the atomic world. Their colors are atomic fingerprints. That's the beauty of the noble gas family. Why are these gases called noble? It's all about their electrons. Noble gases have full outer electron shells, making them stable and unreactive. Most elements seek to fill their outer shells by bonding, but noble gases are content as they are. Their chemical aloofness is why they rarely form compounds. This stability makes them perfect for experiments. They exist as single atoms, ready to glow. Argon protects light bulbs. Helium fills balloons safely. Their inertness is practical and fascinating. Because they don't bond, their true atomic colors shine through. Their noble nature is what makes the light show possible. The color of light that shines from an atom isn't just a matter of chance, it's determined by a fundamental law of nature, captured in a deceptively simple equation, E equals H x EF. This formula is at the heart of quantum physics, and it tells us exactly how the universe encodes color and energy into every photon of light. In this equation, E stands for the energy of a photon, the tiny, indivisible packet of light that's released whenever an atom's electron drops from a higher energy level to a lower one. Each photon carries a specific amount of energy, and that energy is what gives light its color. The F in the equation is frequency. Frequency measures how many wave crests pass a point each second. The higher the frequency, the more energetic the light, and the closer it is to the blue or violet end of the spectrum. Lower frequencies mean less energy, and a shift toward red. Hi is Planck's constant, a tiny, unchanging number that acts as the bridge between the world of waves and the world of particles. It's the key that unlocks the quantum relationship between energy and frequency, and it's the same everywhere in the universe. When a photon has higher energy, it also has a higher frequency. That's why blue light, which is more energetic, has a higher frequency than red light. The bluer the light, the more energy each photon carries. On the other hand, photons with lower energy vibrate at lower frequencies, which is why red light is less energetic. The color we see is a direct result of this quantum relationship. This equation, first introduced by Max Planck and later expanded by Albert Einstein, was revolutionary. It connected the mysterious quantum world to the everyday colors we see, showing that even the most familiar sights are governed by deep universal rules. For example, when a neon atom's electron falls to a lower energy state, it emits a photon with a very specific energy and frequency. That's why neon lights glow with their signature bright red-orange color. Each jump produces photons of exactly the right energy. Argon atoms, on the other hand, have different energy levels. When their electrons jump, the photons released have a different energy and frequency, resulting in a blue-lavender glow. Each element has its own unique color signature, thanks to E, amber HXF. E, amber HXF, is the secret code behind every color in the universe, from the glow of distant stars to the neon signs in city streets. It's the formula that lets us read the hidden messages in light. By analyzing the energy and frequency of light, scientists can decode what elements are present in stars, galaxies, and even distant planets. This equation is our tool for exploring the cosmos. This simple formula explains the rainbow of atomic colors we see in the lab and in nature. Every shade, every hue, is a result of quantum leaps and the energy they release. HXF is the bridge that links the invisible world of quantum energy to the visible world of color. It's how energy, frequency, and light all come together in a single, elegant relationship. That's the quantum secret behind glowing gases, and the reason our universe is filled with such a dazzling spectrum of light. This glowing phenomenon isn't just a lab trick, it's how we explore the universe. Spectroscopy breaks light into its spectrum, revealing each element's unique fingerprint. Astronomers use it to analyze starlight, identifying elements in distant stars and galaxies. Helium was discovered in the sun's spectrum before it was found on Earth. Every element emits a unique pattern of light when excited. By reading these patterns, we unlock the chemical secrets of stars, planets, and more. The glow of noble gases is a small-scale version of the science that maps the cosmos. Lighting up a gas tube isn't just a fun demo, it's a powerful lesson in science. It makes invisible concepts, energy fields, atomic structure, quantum jumps, real and visible. The periodic table comes alive as each element reveals its personality through color. This experiment introduces the wonders of quantum physics in a hands-on way. It honors inventors like Tesla and inspires curiosity about the universe. The glowing tube is a celebration of discovery, showing that science is about seeing the world in a new light. With a little energy and curiosity, we reveal the universe's hidden wonders.